Okay, here we go. Okay, very, very simple stuff. This, we're going to really trim this chapter down a whole bunch. If you are a senior, we'll talk. If you're not a senior, we are going to do a test over this very, very soon. Chapter 7. We'll just do one test. Yes.
Are we going to have a final?
No.
Okay, we'll talk about that at the end.
Yeah.
This is kind of like the final.
500.
Okay. So here we go. So the topic of the day is graphing radicals. Very, very simple. This is right in line with a lot of stuff you've done all year. It's gonna make total sense. It's consistent with other things you've done. If you look at these two functions real quick, these are the two kinds of functions we're gonna look at: square root functions and cube root functions. So here is a square root function over here. Y equals the square root of x. Notice what it looks like. These are kind of the characteristics. It's got a starting place, and then it just goes up and to the right, and it kind of flattens out with time, and that's it. That's what a square root function looks like. We'll get into a little more specifics in just a second, but that's it. That's what they look like. Starting place, up to the right. This is a cube root function. It looks very similar, only notice it's, instead of just going up to the right on one side, it then goes down to the left on the other side, and it's got symmetry. Okay, let me draw these a little bigger, and we'll discuss them in just a little more detail. So let's start with a square root function. Okay, if we're just graphing y equals the square root of x, it starts at the origin, and it's going to go over 1 and up 1 through this, so it's going to go through the point 1, 1. And then we just kind of sketch it from there. It just looks like that. So that's the square root of x. Real quick, what is the domain of this function? Now that's a word we haven't used in a while, but it's an important word that you're going to use a lot more next year than you did this year. So what's the domain of this function? What does domain mean? The set of what? What values? Well, okay, yeah, but I want to know when we talk about the domain of a function, what are we talking about? Say it again. Well, kind of, but okay, it has to do with the domain. See if this rings a bell. I'm not sure if that question I asked, maybe you don't know what I'm trying to get you to say. The domain is the set of all the x values for a function, right?
Oh, like the x value?
Yes. So if this is the x-axis and this is the y-axis, right? The domain, that's all the x values that we can plug into a function. Okay. When we look at a graph, it's really easy to find the domain because it's literally just all of the x coordinates that are graphed. So let's take a look at the domain up here now. Do the x values have a starting place on this graph? They start at what x value? 0, and then they just get bigger from there, don't they? Yes. Right? So the domain, how would we write that? Okay, but I mean, how do I write that set of values? How do I say all the x values from 0 bigger? What do you think? Right here, Braxton. Greater than or equal to 0, bingo. So x is greater than or equal to 0. Okay, makes sense? So what have we done there? Think what we just did. We excluded all the negative values. That should make sense. That should make sense because we said from the very beginning of the year there are two things that we can't do for real numbers, right? We can't divide by 0, and we can't, get all the phones and stuff away, please. We can't divide by 0, we said, and we also said we can't do something else. What else can't we do? Divide by 0, and we can't, what? Okay, right here, can't take a square root of a negative number. And we started off saying square root, and since then, like just recently, we've said, well, really, when we say square root, we mean any even root. Square root is just the easiest example of even roots, but any even root. So this is the reason that we have this domain that's restricted is because it's a square root function, right? You just told me, or reminded me, that you can't put negative numbers inside a square root function, and so doesn't it make sense that the x values we can put in there have to be restricted? only include the positive ones or zero, we can't include the negative ones, right? So that's why this has to be our domain. Has to be all, and the way we say that in math, we'd say that's all non-negative numbers, the set of non-negative numbers. So 0 or positive numbers, right? Make sense? Okay? All the x values that are graphed, and the reason it's restricted is because it's an even root, and we can't take an even root of negative numbers. So the x values we plug in have to be positive, right? Okay, what about the range? If the domain is the set of x values, the range must be the set of y values. Very good. So what about the range then? What are the y values that are graphed here? Once again, is there a starting place? 0. Yeah, the y values start at 0 and just get bigger, don't they? You ever see that? The x values start at 0 and they get bigger in the positive x direction. As we graph this thing, we're graphing, sure we're graphing up, but we're always graphing to the right of 0, aren't we? The y values, same thing. They start at 0, and as we go to the right, we're always going up. So how do we say the range then? Y is what? Greater than or equal to 0. That's it. Okay? Now, what if we compare that to a cube root function? Let's just graph them on the same graph here. Cube root function looks almost the same. So in red, we're going to graph y equals the cube root of x. It also starts, well, starts is kind of the wrong word. It goes through the point 0, 0. It goes over 1 to the right and up 1. It looks almost the same. It's just a little bit steeper at the beginning, and then it flattens out just a little bit quicker. But it's got the same basic shape, but it also extends back the other way. It goes up and to the right, but it goes down and to the left also. Like that. And it's got symmetry. You see the symmetry here. If I put a tack in the board right in the middle of this thing, at the point 0, 0, and if I spin this 180 degrees, wouldn't it line up with itself? Yeah. That's called rotational symmetry. So the cube root function has this rotational symmetry that the square root function does not. Okay, but they look almost the same. What's the domain and the range of the red function? So for the let's start with the domain. So we're looking at the domain of a cube root function. Okay, does it start anywhere?
Not really.
Not really. It doesn't, does it? It doesn't have a definite starting place. It goes in both directions. So let me ask this in a different way. Are there any restrictions on the to the domain of the red graph? Say it again. Okay, but these are cube roots. These are cube roots, so they're okay. Now, and that's part of the rule. Remember what we said? It's been a little while ago, but we did say that for cube roots, is there a problem putting a negative number into a cube root or any odd root? No, it was fine, wasn't it? The cube root of -8 is -2, right? That's okay to do. We just can't take a square root of a negative number and get a real result. Okay? So the answer is there are no restrictions. Anything goes. All real numbers work for x values in a cube root function. And the way we write that is capital R. This means all real numbers. What about the range? Does it start anywhere? No. It just goes up forever and down forever. It kind of flattens out, but it's always increasing if I go to the right, and it's always decreasing if I go to the left. So what do you suppose the range is? Infinite. It's also all real numbers. Okay? No restrictions. All right. Very simple, right? Those are the shapes of those graphs. Now the last step that we want to get to, and it's a really kind of small step, is we want to be able to draw different kinds of square root and cube root functions. And really all we need to be able to do to draw any possible square root or cube root function is we need to be able to change the starting point, or that center point of symmetry for a cube root function. We need to be able to slide that around on the xy plane, and we need to make them maybe start upward or start downward. And we got to be able to stretch them vertically a little bit, right? Change their shape. But that's all we need to be able to do. If we can do those things, we can draw any possible square root, or cube root function, right? So how would we do that? What if we want to draw, draw a square root function, but we want to start it up here instead of right there. Okay, this is gonna look really familiar, because instead of writing this as y equals the square root of x, we're just gonna write it as y equals a times the square root of x minus almost h plus k. Okay, just like we did with parabolas and like we did with absolute value functions, where h and k, in those cases it was what we call the vertex, right? It's not really a vertex here, but it's the special point. H and k are the coordinates of the starting point of a square root function. So what would it look like, I suppose, if I did this then? What if I wanted to draw y equals the square root of x minus 2 plus 3? What are the values of h and k there? Negative 2 and 3? 2 and 3, right? Remember, it's that same old trick. H is being subtracted from x, right? So you gotta be careful about the sign. So hk in this case would be 2, 3, so we would just go over 2 and up 3, and that's our starting place, right? And then from there, we'll just draw a normal square root graph. Okay, we're just gonna go over 1 and up 1 to create our second point, and there it is. Okay, no big deal. All right, let's try another one. I'm gonna get trickier. Sure.
So are we gonna have like find out what graph it is?
Yes. You can do two things. I'm gonna give you a function, you're gonna pick the corresponding graph, and I'm gonna give you a graph, and you're gonna have to write the function. Those are the two things you'll have to do.
When you start at the bottom, you just start at where you just started right there.
Yes, right, you start at whatever h and k are. That's the starting place. Okay? So here, let me draw this in different colors so you can see it better. It starts over 2 and up 3, and then it goes through the point over 1 and up 1, like a normal graph, off to the right. Okay? Let's try another one. So how about this one then? Let's try y equals negative 2 square root of x plus 1. Try that. Okay. So first of all, what are the values of h and k? Because that's going to tell us where we start. Negative 1 and 0. Good. Everybody see that? K is 0, h is negative 1. Good. So there's our starting point. Okay, now what do you think this negative 2 means? Yeah, it's kind of like a slope in a way. When you multiply a function by a number, remember, that's how much you're stretching it vertically, right? So here's the meaning of that for a square root function then. This is the value of a, isn't it? So if a is negative 2, what that tells you is, if you scoot 1 to the right, instead of going up by 1, if a is not 1, if a is something else, when you scoot 1 to the right, that tells you how far are you going to move up. So if I scoot 1 to the right and go up by negative 2, what is that really accomplishing? Yeah, everybody see that? I'm going to go over 1 to the right, and I'm going to go up by negative 2, which is the same thing as going down 2. So that's my second point right there. And this is an example of a square root function that opens down. Okay, make sense?
What if it's a square root, it always goes to the right?
Yes. Yes. There is a sneaky way to make it go to the left, but we're not going to talk about that. I'll tell you what it is, though. All you have to do is you just plug in, you just trade x for negative x. That's all you do. But we're not going to do that this year. Okay? Make sense? Okay, let's try one more of those. Let's work backwards this time. So I'm going to draw the graph, and I want you to write down what the function is. take a second. We need scratch paper. Try writing this down. You're welcome. Back here, everybody need it? All good? Okay. So everybody try this. If you get this now, this will be a piece of cake on the side.
For today. Why is it going down?
Oh, yeah, what's the deal there? It's going down. So you gotta, that's gonna affect the equation that you write down. So maybe first thing, try to identify H and K. Okay, let's see. Rachel, did you get H and K?
Yeah.
What'd you get for H and K?
Or 1 and 0. I use 1 so plus.
So, say it again.
It'd be x plus 1.
X plus, okay, oh, okay. Inside, but now, this is the point with HK, right?
Oh.
Okay.
Oh.
It's hard to tell on my crappy drawing, but,
Plus 2.
okay, so,
That's the point that would be, how do we know which one we should do?
okay, because H and K always corresponds to the special point, which is the starting point.
Oh.
Okay, so this is the point we're interested in, right? Right here. Okay, so one more time. You want to revise answer?
Is it at -2 on that?
Okay, -2, so H is -2, what's K? 3. Okay, good. So H and K are -2, 3. Very good. Okay, that's 2 of the 3 numbers that we need. The only other one we need is A. What do you think? Alyssa, what's A? Negative what? It's negative something, you're right. It is 3. Good. Okay, because we go 1 to the right, right? If we scoot 1 to the right, it looks like we're going up by -3, right? Everybody see that to get to our second point here? So A is -3. So let's put it all together then. What is this function? Y equals -3 square root. It's a square root, not a cube root, right? Okay, good. X minus -2, so X plus 2 plus 3. Everybody see that?
Yep.
Okay, second part of this, though, that you're going to be asked to do on this kind of question, I'm going to ask you for the domain. So what's the domain? And it's very simple, though. You're going to see a pattern here, if you haven't already. What's the domain of that graph? Domain is X stuff, right? So your statement's always, is it R?
No.
No, because it is restricted, isn't it? It does have a starting place. What do you think, Dylan?
X equal to less than or equal to?
X is greater than or equal to what?
0.
No.
-2.
-2. Okay, the answer is always, everybody look at this for a second, please. This is going to make this one really simple. The domain of a square root function, you might have noticed, we've looked at a few examples, it's always going to be, every time, the domain of a square root function is going to be X is greater than or equal to its starting place. And where is its starting place always going to be? H. Yeah, how about that?
Or equal to or greater than equal to or less than?
Greater than.
Greater than or less than?
Now, does everybody see why? Everybody focus up here, please. Focus. The domain is the X, we're talking about X values, right? So if I start with my pencil right there, my pen right there, the X, as I draw this graph, would you agree that horizontally, I'm always moving to the right as I move down or up? Does that make sense?
Yeah, so it's always be
Greater
greater than or equal.
than or equal to, so the domain is always, for a square root function, x is greater than or equal to h. Yes, sir? Oh, yeah, you might want to do that.
Oh man, mine are too.
Sure they are, Debbie.
My back windows, they're only like this much. No, I leave my windows down because I have no air conditioning. Yeah. Yeah. What are you, mine too? You I don't have panic buttons, and I got like 89 gigs of crap. I have no air conditioning.
Or POS.
It's a piece of. Lock it, Braxton.
I will.
Okay,
Go.
all right.
Boy, if I told you I had a car, can I leave too?
No, All right.
But I need to order them.
no, it's supposed to pour. I mean, it's supposed to
Are
really
you
pour.
serious?
Okay, here we go, back up here. Here we go.
I know, all my house windows are starting.
Okay, here we go. I'm waiting. Okay, what about the range?
X is
That'd be-
less than or equal
Okay, you mean y?
to, or, yeah,
Okay, y is
less than or equal to.
less, you're right. Now, think about y, is less than or equal to 3.
Less than 3.
Okay, now how come, now you gotta be careful with this. Notice that the starting value for the domain is always h, right? We said that the domain is always x is greater than or equal to h. Now, the starting value for the range of a square root function is always gonna be k, but a square root function can open up or downward, depending on the sign of a, right? So if it's opening downward, Jeremiah, if it's opening downward, then we're gonna need all the values that are below k, right? Starting at k and below, so we need to use a less than or equal to sign. Make sense? Okay. Now, easier than that, it seems like the cube root one would be harder, but it's actually easier because the domain and the range are always the same. What are they always gonna be? All reals, yeah. Okay, so let's try a cube root example. How about this one? Let's start off, let's graph one, and then I'll write one and I'll draw a graph and you write the function. So let's try one of these. Let's try graphing y equals positive 3/2 times the cube root of x minus 1 plus 2. Okay, so what do you think I do there? What are the values? We gotta find the values of a, h, and k. What is a? Positive 3/2. What are h and k? 1 and 2. Okay, so now for a cube root graph, what do you suppose h and k corresponds to? Well, what do you mean by that?
Center.
The center point, right? Because it goes in both directions. So it's going to be where the tack goes. It's that point of symmetry, right? Okay, so we're going to put, there's our tack, over 1 and up 2, right? Okay, so that's half the battle or more. What about a, though? What do you think a is going to tell us for a cube root graph? Sort of the same thing, isn't it? Right? It tells us, just like before, if I go 1 to the right, how much am I going to go up or down here? I'm going to go 3/2 up or down? Up. Good. So the same as before, it tells us if we go over 1, we're going to go up by a. So we're going to go up by 3/2. Okay, everybody see? Okay, so to the right, it's going to look like this. It's going to start at HK and go up like that. Now, there's another part of this, though, right? A cube root graph goes back to the left in the opposite pattern, correct? Aha. So we're going to go back 1, and A also tells us how much we go down if we go to the left by 1. So if we go to the left 1, we're going to go down 1.5. So it looks like that. Everybody see that? Okay?
Wait, don't move it.
I gotta be
Okay.
worse. Or let me drink the water.
Okay, questions on that?
No, just leave it.
Okay.
Okay, you're good. No.
Okay, so last,
Not yet.
Thinking out loud.
Hold on. You're good?
okay, you get it?
Yep.
Okay, in the back, Tiffany, you got it?
Yeah.
Okay. All right, so last one. See if you can do this one now. I'm gonna draw the graph.
We're gonna figure it out.
You're gonna figure it out, exactly.
Oh, wait. Another 5 steps.
Okay, write it down. Let's write this one down, please.
What are you doing?
Man, that's a pretty crappy cube. But you get the idea.
I really.
Struggle with my cube root.
Okay, I got it. So are we gonna be able to go to the last one?
Yes. We're gonna finish this up. Yep.
Hey, what about the whole senior thing?
We'll get there. Okay, so H and K. Judith, what are H and K here? What do you think? Kind of hard to tell. Okay, but which is the one that's gonna be H and K? The middle one, yeah, right here. Well, okay, so what's the value of H? Negative, right? I know what you're thinking, but the actual coordinates of that point are -3, -3, -2. Okay, good, right. So that tells us, is this a, is this a cube root or a square root graph? Cube root. Okay, so we know, we're gonna get A in a second, but we know H and K. So I'm gonna have inside the cube root, x plus 3, and then outside, -2, okay. What's A though? It's 1? -1, how come? Tim, how come? You're right. Ah, okay, good. Everybody see that?
So you go right one, down one.
Yes, if I go over 1 in the positive direction to the right,
But what if?
I'm going down by 1, right? Okay, but everybody make sure everybody gets this. Okay, so remember what A tells us, it's like a slope. If I go to the right by 1, it tells us if we're going up or down. Okay, the left is gonna be the opposite of that. So just focus on the right one. If we go 1 to the right, we go down by 1, so therefore A is -1. So how would I finish this? What do I put out front?
Negative side.
Yeah, right?
Negative one. Why do we all look like men?
Isn't that saying -1? A is -1 if I put a negative sign out in front?
Yes.
It does.
Are we done?
We're done. Makes sense?
Oh.
How about that?
Oh, yeah. What were you saying?
Oh, yeah, okay.